Assalamu alaikum and hi. My name is Yahya Abshir Jama and my matric is BE190021. I'm gonna present my part. Introduction. Nowadays, electrical power is basic necessity in daily life, whether for rural areas or densely populated urban areas. Electrical power is generated by the generator by using various sources as the raw material such as coal, hydro, wind, and fossil fuel. Then it will be distributed based on demands from the user through the transmission line. Electrical power can be distributed by using overall heat lines or underground cable depending on the geographical aspect of the area. Objective is to design the high voltage insulator by using appropriate methods in industry in the formal literature. To draw the proposal design using 2D and 3D drawing software and simulated the high voltage of EM field distributions to proposal prototypes. To analyze the performance of the prototype, one studies by environmental impact and work out the test setup for appropriate of higher voltage testing that considers correct equipment, safety, and practical producers. Scope of work. The scope of high voltage insulator is listed below. The high voltage insulator can be withstand up to 132 kV voltage. The type of high voltage insulator is string suspension. The fittings used for the high voltage insulator are cap and pins. The high voltage insulator is made up from a glass ceramic insulator. The maximum length for the high voltage insulator is 1540 mm. Thank you. That's all my part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rusyada binti Ismail. My metric number is CE Y90182. Okay. So basically, in this project, I'll take part in technical summary of FEA simulation software and the process flow of the FEA simulation to the prototype. Alright. So, first, we look at the part 1, technical summary of FEA simulation software. Alright, we choose to use the FEMM version 4.2 software to simulate our insulator in order to analyze the high voltage field and electric field. Okay, so the 2D design of the insulator must have the correct properties and sizing in order to ensure that the field analysis will yield accurate result. Okay, so this is the properties of the geometry models. Okay, as you can see in my screen, we choose 132 kilovolt, and then the material of the air, permittivity of the air is 1.0, permittivity of the silicon rubber is 4.3, permittivity of the FRP is 7.3, permittivity of the steel is 1.0, the permittivity of wet is 81, and lastly, the permittivity of dry condition is 1.0. Alright, next, part 2, process flow finite FEA simulation to the prototype. Alright, so this is the flowchart of the general process. The flowchart of general process shows designing an insulator for the project. So from start, study about an insulator, gather the data and information related to the insulator, which is we want to use glass, polymer, or other else material, and then we design an insulator 132 kilovolt transmission line using AutoCAD, And then with selection of type and material, like glass. Then draw 3D model using AutoCAD. Then design 2D drawing using FEM software. From AutoCAD, we insert to the FEM software. Then we analysis in FEM software. If yes, we can obtain the result and do the discussion of the insulator design. If no, we need to go to design to the FEM software. Alright, and then we end the discussion. So this is the block diagram of FEMM simulation process. First, in the FEMM, we set the problem, and then we modeling 2D design, and then we set the boundary material, and then we mesh, and then lastly we run and display the result. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Akmal bin Muhammad Hairani. Metric number C190162, and today I will present for result of FEA testing of insulator in both dry and wet condition. First, I will speak about the single base insulator. Here's the voltage intensity for our single base insulator, which is made up of conductor from steel, porcelain, and iron. This is a cap and type insulator. And here's our electric field intensity. As we can see, the color for the electric field intensity for both condition for single base is quite the same. Next, for full string insulator, this is our result for FEA simulation. At my left side is the dry condition, and at my right side is wet condition. From both figure, we can see that the voltage intensity at the left side, which is the dry condition, is higher. This can be seen by using the density plot. The brighter the color of density plot, it has a higher level of voltage intensity, and from the figure for dry condition, it has a more brighter color than the wet condition. And here is the graph for voltage intensity. My left side is dry condition, and for my right side is a wet condition. And for the dry conditions, we can see from both graphs, it started from the same level of voltage intensity, but as the creepage distance increase, the voltage intensity will reduce. And for the dry condition, it takes about more than 3,500 inches to make the voltage intensity reach zero, and for the wet condition, it takes less than 3,500 inches before the voltage intensity is got to zero. And next is the electric field intensity. For the electric field intensity, both conditions have quite the same colors, and it's like the single base insulator. So it is not much difference between in terms of electric field intensity for both conditions for the insulator. Yeah, here is the graph. For the dry conditions, the difference between these two graphs is dry condition has the spikes occur quite frequent than the wet condition, and spikes are higher than the wet conditions. From this, I can conclude that the electric field intensity for the dry condition is higher than wet conditions, even though the first increase in the wet condition is higher than the the dry conditions. So we try to conclude the condition that fuel intensity is higher than the wet conditions. This is from me. Thank you.
Assalamualaikum, my name is Nabil Fikri Berosli, metric number CE190212. So I will continue to technical summary methodology of FEA simulation. The condition of the insulator with the right properties was simulated using FEMM software based on the methodology process. Additionally, to avoid any mistakes during the simulation processes, the prototype insulator was simulated step by step. The data of the result can be produced in detail, and the issue, the simulation process, can be resolved by referring to numerous resources. FEMEA is a methodological approach for identifying, assessing, and documenting possible errors in a product or process design. When these failures are recognized, their effects on performance and safety are as well. According to table 6.1 below, the failure mode has been categorized, and one of the reasons of this project can be complete successfully and adhere to the methodology is the group's teamwork. So this table show the failure and the causes of its failure. So first, cracked insulator. So the causes is because of failure of the material, excessive or impact force. So ceramic material was used in the project as an insulator. One of the best insulator is ceramic. Its low mechanical strength, however, means that it will break after a falls. And second, weather condition. This is because of nature failure. Unexpected natural disaster, bad or unfavorable weather, such as thunder, rainy days, and so forth, could cause issues when performing the insulator test. And then aging. So the causes of this failure is external failure. An external failure, also referred to as aging effect, is a result of a failure. It happens when an insect or bird nest appear on the insulator surface. And then the breakdown. So the equipment failure is the cause of this breakdown. A breakdown may result from an equipment failure that causes a leak of any issues with the circuit or cable. And the last one is vandalism. This is because of human failure. One potential outcome of unfavorable circumstances such as vandalism is human failure. Some careless individuals cut the insulator's wire and throw stones. So I will continue to the conclusion from FEA work. So in the conclusion, we are able to successfully simulate the distribution of high voltage and electric field from the insulator tested by this group using the result from finite element method, FEMM. Using FEMM software, we first finish building an appropriate insulator that complies with the desired standard requirement. The polymer insulator sheet with make up the majority of the insulators, 16 sheets, and suitable for injection with 132 kV are its primary distinguishing features. By testing the HVAC system while looking at the potential and electrical field distribution all around, and testing is both dry and wet condition on clean and uncontaminated surface, we can see how the insulator responds to electrical stress. We can discover the effects of these materials from how well the design insulator performs. Because high voltage testing is essential for evaluating equipment before it is put into service. This project also teaches us about the significance of safety in high voltage engineering. When performing high voltage testing, all safety precautions must be taken into consideration. So I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Mustaqim bin Rosli. So now I will continue the presentation for testing information. So the HVAC test was selected as the electrical stress test technique because it used HVAC cascaded transformers with TOV temporarily over voltage as the HVAC resonance set. So this picture here is the resonance set that we use. So in this test, the circuit is powered by a cascaded transformers with a voltage of 200 kV or more, and the output voltage is monitored. So the diagram here is showing the system of the cascaded transformers supply. So this test is consists two tests, which is wet and dry test. So for the wet test, it's required the artificial ramp to restrict the conductivity and the flow rate specification, and it is to create the bi-nozzle that completely cover the sample of the surface. So for the dry test, there is no artificial rain is provided to the sample surface, and it is must be the first one that need to be conducted. Okay, that's all from me. Thank you.
Assalamualaikum. Hi, my name is Muhammad Fikimi bin Shukri, CE100142. Okay, so for my part, I will explain about the HVAC test. So first is about the COSH, which is the control of substance hazardous to health regulation, ending with chemical data sheet. Okay, COSH is the law that mandates employer to monitor and regulate hazardous chemical. Okay, so worker exposure to hazardous chemical can be avoided or reduced by, which is there are 8 of them: finding out what is the health hazard are, deciding how to prevent harm, health risk assessment, providing control measure to reduce harm to health, make sure they are used, keeping all control measure in good working order, providing information, instruction and training for employees, providing monitoring and help surveillance in appropriate case, and planning for emergency. So this is the COSH assessment form. Example of this is our COSH assessment form for handling chemical in the laboratory of our testing HVAC test. Okay, next is about the HVAC test, which is the HVAC cascaded transformer temporary over voltage test setup. Okay, so this is our test setup, which is for the TOV of HVAC cascaded transformer. Okay, so as you can see over here, this is the cascaded transformer. This is our sample, which is the insulator test object, and this is our spraying system for the wet condition, and other is some safety measure, which is the overcurrent relay, overcurrent shunt resistor, and the overcurrent relay will be read by the overcurrent relay control box and to the main control box, and then to the data acquisition, and then the lab view for the monitoring system. Okay, so for the explanation, the test setup is usually to perform to qualify the device operate safely during read electrical condition, a way to check effectiveness of its installation. Okay, HVAC test is important because it will determine the type of amount of voltage applied and acceptable current flow to the insulator. Okay, so the test setup requires several equipment such as like this, the cascaded transformer, overcurrent relay, thermal camera, spraying system, shunt resistor, and the monitoring system. Okay, so the type of power supply is that used is the cascaded transformer, which is this. Okay, the cascaded transformer is regulated from the 100 kilovolt until 300 kilovolt. Okay, so the shunt and the high voltage relay are usually connect between the supply and the test object. Okay, this over here, to prevent any hazardous happen, so we put the shunt resistor with the HV relay. Okay, so the function of shunt resistor is to control the voltage and the current that is induced through the test object, and the HV relay is to ensure the safety of the test whenever the testing, if the testing is having some breakdown. Okay, so this is about the monitoring system, which is the main control box, data acquisition box, and monitoring device. Okay, this is about the overcurrent relay, because it can limit the flow of high current from flowing through the other electrical equipment. Okay, this is the measuring device. Okay, this is the lab view system, which will monitor the output of waveform that will be produced by the testing from the overcurrent relay measurement and the thermal measurement. And lastly is the spraying system, which is, as you can see before, the water pump and the water tank will supply the water to the spraying for the wet testing. Okay, so for the safety aspect, so the safety aspect is while testing the high voltage cable and other equipment, it is necessary to follow some specified safety recommendation and norms. Okay, it is critical to follow them when working in high voltage equipment, okay, to guarantee the workers are protected from all type of electrical shock that workers are working. Okay, so firstly, we need to use the quality HV tester, okay, and familiarize with the power button of the equipment on off. Ensure the circuit power is switched off before begin the testing. Remove any kind of metal jewelry like watch, necklace, or anybody from the body before handling this of this type of high voltage test. Okay, and avoid wearing the short skirt or loose apparel, and because it can expose to the high voltage equipment. Do not leave the hair open. Wear the PPE, which is protective equipment precautions, such as the safety glass, safety glove, and other safety guidelines. So ascertain the experiment is being carried out by at least 2%. Make sure the testing is arranged by 2%, unless okay, separate high voltage equipment in HV tester from low voltage equipment and tester, so that their function and operation do not conflict with each other. Ensure that all DC and AC power source start at 0 voltage. It is critical that all items be kept at least 1 inch away from the high voltage cable. Okay, and make sure the HV tester that working with have a single power button that can be used to turn off the high voltage in event of an emergency. Keep in mind while purchasing HV tester that the equipment include an indication that will signify the high voltage output. Okay, so that's all from me. Thank you.